Hello everyone, welcome to my video tutorial series. This will be a three-part video series on doing shadow mapping in WebGL. Now, there's several different ways for you to do shadows in video game programming or graphics programming in general. One of the more popular ways is to do pre-baked lighting, which would be you have a static light source and you assume it's somewhere, right here in the middle of the room, and you just bake into the textures what all of the where all the shadows are, and that is really cheap. What I'm going to be covering is dynamic shadow mapping. So what's happening here is every single frame I'm actually recomputing where all of these shadows are. And I'm doing that by creating a texture. It is a cube map texture, so it surrounds the entire point of view of a certain object. The object in question is the light, so let's see if I can pin down the light. You can't really tell because the light's moving, but if I were to get exactly on the position of the light, you'd notice you wouldn't be able to see any of the shadows. That's more or less how the shadow mapping technique works, is it takes a picture of the entire room from the point of view of this point light. Everything that it can see is lit by the Phong lighting model, which I've covered in one of my other WebGL tutorials, and everything that it can't see only receives ambient lighting. So you can see down here the table in shadow is still slightly purple, it's just not very purple. And you can't see it that much because there's kind of this shadow edge right here just from the angle of the lighting, but you can kind of see where the monkey falls in shadow. It's still receiving some ambient light. A couple things I am going to note is this is very expensive. Dynamic shadow mapping takes up a lot more computational power. On all of the computers that I tested this particular demo, I was still getting 60 frames per second because there's not very much going on in this scene. But if I was to have, multiple light sources or things like that, it gets very expensive, so that's one thing to keep in mind. Another is WebGL. This is the running WebGL demo, by the way, the one that we'll be creating by the end of the second video. But anyway, so WebGL, its texture formats are a little bit weird, and I ran into a problem here. The default one is gl.unsigned byte, which means that the textures that you generate have 8 bits of precision for each color channel. Now 8 bits is not very much precision, and that is what we're having to work with here. There is an extension that lets you use full 32-bit floats, so you have full 128-bit per pixel precision. That is not supported globally across the board. That is required by an extension. So throughout the course of these videos, what I'm going to do is in the first video, let me pull up this right here. In the first video, we're just going to set up the scene with the animation. I'm actually probably not even going to do the whole light moving, because it's going to make the second video a lot harder. So right here we just have regular Phong lighting model, no shadows. This is what we're going to generate by the end of this video. By the end of the next video, we're going to apply shadows. So what you were looking at before, that is what we're going to get by the end of the second video. In the third video, I'm going to apply the GL floats, because there's a lot of things that just look so much better when you're using 32-bit floats for everything. So let me show you just one of the things that's absolutely horrible. If you look at the side of the couch, look at all that residue. This is unacceptable. So this is one of those limitations. If you're using WebGL like I'm going to be showing you how to do, you're definitely limited in what you can do. Hopefully I'm going to be getting to some actual OpenGL C++ and DirectX 12 tutorials. If I do so, you'll be able to see definitely much more of the power of this process. But you've listened to me ramble on long enough by now. Let's get this moved over. And what I want is a new Sublime text window. So like I've been doing in other tutorials, I'm just going to set up somewhere in here, let's see, under Indigo CS, and I think I already have something there. I'll just make something, shadow mapping video. And I'm going to make an index.html, just like I've been doing in every other video. Oh, by the way, I guess while I'm setting things up on my end here, I have an Introduction to WebGL series. It's labeled 1 through 5. If you watch those, I expect you watch them in order, and I expect in this video that you've covered the material, though I don't expect that you've necessarily seen my videos, and I don't expect that you've seen any other ones. So I should be covering this from someone who has some experience with graphics programming, but not necessarily has watched my entire suite of videos. That'd be unrealistic to expect of you. So let's see. I'm going to move these back over. One thing I'm going to do is I'm just going to put in some inline styles. And you can see right here that the canvas, takes up the entire browser window while maintaining a 16:9 aspect ratio. But there's no margins, no padding, anything like that, so I'm just going to put that in really quick. So for everything, which will be only our canvas element, maybe it'll be more, I really don't know CSS for crap, so I have no idea what this is doing other than it seems to be working. Yes, I'll buy Sublime eventually. Let's see, and I want to make a canvas element. I'm just going to copy it in from what I've been doing before. I'm just making a canvas with GL Surface ID. If they don't have HTML5 supported browser, I yell at the user. And then I'm going to have several JavaScript files. So the entry point of the application I want to be in this app.js. And because we're doing an onload function and we're going to be calling this init function, this is going to be the entry point of our application. So it doesn't matter what order I put the script tags in. This won't be loaded until all of our scripts have been loaded anyways. So let's see. Script source equals, what else? Well, I guess first let's open a new PowerShell instance. Let's actually get rid of the old ones. Oh, I think I might have closed the wrong one. Is the server still running? No, it's not. That's good. Okay, so where did I put this? I put this under Fgame Programming, Indigo CS WebGL Tutorial, Shadow Mapping, Video. Good, this is where it is. So I'm going to use Bower to get a couple of components that I will be using. Whoops. Bower install, and I want GL Matrix and Async are going to be the two names. And while that's working on it, I'm just going to point you to them where you can find them outside of Bower. So if you want async, it's just right here. You can go to the async. It's on kolan/async. This is a great library for doing certain asynchronous functions with Java. It has like a map and all that. And you can, if you want, just download this async.js or async.min.js. This is really all that I'm using. So you could just grab this if you wanted. For the GL matrix, this is it's another one of those projects that this allows you to do a lot of the math, so you don't have to do all of your own matrix work. It takes care of that for you. Again, under dist, GL matrix min, this is what we're going to be using. It's actually kind of a funny story with this GL matrix. There was a couple of pieces of functionality that was missing when I started to make the when I was preparing for this video, when I was making that demo. But in how long it's taken me to create this video and get everything all ready, the pull request that I put in to fix those missing components has been approved and is actually part of what you download when you get the GL matrix from Bower or from GitHub. So all's well that ends well, I guess. Alright, so these two files, I'm actually going to move this up because these are not our files and I'm going to separate it. These files I am all going to write. The util.js, remember how I said I didn't expect you to see the other videos? I lied just a little bit. I'm going to be pulling just a couple of tools that I've written from other videos. Models, I'm going to be writing a couple of I don't need app.js twice. I'm going to be writing a couple of things, so like a model class, it's just going to store the vertex and index buffers, nothing too elaborate. And then I'm going to have two scenes. What I'm also going to introduce in this video is the idea of making a loading screen. You know what, actually screw that. I'll do that in its own separate video. So I'm just going to make one scene, and that's going to be the light map demo. Alright, so let's start off with our util.js. Whoops, I should probably save this. Util.js. And I'm just going to copy this over from what I've had in other videos. I'm going to really briefly talk about what it is. So this first one is a get parameter by name. Let me zoom in just a bit so you can see a little bit better. This get parameter by name, pretty much just, so you can see over here I have this question mark ss equals 4096. It's just to grab this parameter. I can set some variable ss with the value of 4096. Add event and remove event, these two go together. This is how I'm going to attach event listeners to the window. The ones that we're going to use are on resize. The resize is important because we want to keep the canvas taking up as much of the screen as we can and centered. These were taken from this Stack Overflow post, or at least this was. I had to write this one manually, but whatever. Then we also have load text resource, load JSON resource, and load image. These are three asynchronous functions that they go out, they find a URL, and using kind of a JavaScript standard notation, they invoke a callback with the result of what other the text is, or if it's JSON object, it parses the object, and if it's an image, it grabs it as an image object. So you can look at those. I will be posting the source code online, but those are not what we're interested in writing right now. So kind of similar with the models.js. Some of this I'm going to write in real time right now, and some of it I'm just going to skip over. So the model, let's actually, I'm going to write that with you, because there is also something I wanted to change. So for this demo, I'm assuming that all of our models are just going to have a list of vertices, indices, and normals. These are the three properties that we use to compute like a generic lit scene. And then I'm also going to assign a color to each model. I'm going to assign it per model instead of per vertex, just so that, you know, we can have kind of like a teal couch and a purple table, and we don't have to waste, you know, all this time interpolating those values, because really I just want them to be solid colors. So the only pieces that I'm really interested in when I'm rendering are, I know I need the actual lists as input here, but I only really care about the buffers. So let's create those buffers. We want a vertex buffer. I'm just going to call that VBO for vertex buffer object equals gl.create buffer. I want to create an index buffer object and also a normal buffer object. And I am going to keep these in two separate buffers instead of using just one index buffer. I don't have a good reason for that. Well, I do have a slightly good reason, and that's we are going to be using the async to JSON piece of code up here that lets us take Blender files. I have a scene created in Blender, and it lets us export it into a JSON file format, and the vertices and normals are different in that. So that's a good reason, I guess. Let's see. I also want a world matrix associated with each one of these, so I'm going to say map4.create. I remember in an earlier video I didn't even know you could do that. And then finally, a color. Great. So these are going to be all the properties we're going to have. Let's now actually bind these buffers with the data that they contain. So bind buffer. The first one we're going to do is the vertex buffer object. I'm going to bind that. It's an array buffer. And let's attach the associated data, array buffer, new float32 array, vertices, and gl.static draw. Great. Cool. So let's do that with the other two now. So now for the normal buffer object, buffer data, gl array buffer, new float32 array still for these, and this will be normals. And then finally for the index buffer, bind buffer is an element array buffer. Whoops, GL buffer data, element array buffer will be new uint16 array. This is the type we use for index buffers. And GL static draw. Finally, just to kind of clean up, let's clear the buffers so we don't have anything bound. I don't have a good reason for doing this other than it makes me feel better about myself as a person if I do. Great. Another thing I'm going to do is I'm going to write a quick little thing that creates a shader program from pieces of text. And let's see. This is going to be just a function though. It's not actually an object in of itself. So create shader program. Again, we need an instance to a GL context, and I'm passing that in as parameters right here because we don't have a global variable because I refuse to have a global variable. We need our vertex shader text and our fragment shader text, as well as, you know what, I'm not going to do this asynchronous because it's not an asynchronous thing, so doing it in an asynchronous style would not really help us at all here. So I'm going to create our vertex shader just locally. Vertex shader. gl.shader source. And I'm just kind of breezing over this part because all of this, by the way, these are things that I covered in my first two Introduction to WebGL tutorials. So if you're unfamiliar with what this is doing, take a look at those videos and that should clear it all up. And you know what? In fact, I'm just going to copy the rest of this function from my notes, and then I'll cover it quickly. I don't want to waste too much time on the stuff that you should know how to do. So pretty much I'm just creating vertex shader. I'm setting the source to what we passed in, same with the fragment shader. I'm compiling. What I'm going to do though is instead of using this callback that I was using in my demos, I'm actually going to return an object. So I'm going to return error. Yeah, error. And then I'll just return that text. I'll do the same thing down here, except for this is for the fragment shader. I want fs there. Nope. So this is where I actually link the program. And this is where I validate the program. Okay. So at this point right here, I should have a complete this program variable is going to be the actual GL program that we're interested in. I am going to just return that. Let's see. Should I just return program? Yeah, that's what I'll do. And then outside of here, I'll check it by saying, like, if result.error, then do something. Otherwise, program is GL program. Great. Cool. So this is the only one that we're going to use immediately next. I do have one more that I'm going to be adding here. You know what? Actually, let's add it right now. And this one is one that I'm going to cover. You can see in the demo, which do I have... Okay. No. Well, whatever. Oh, I shouldn't have closed it, should have I? Oh well. You could see in the demo that I was controlling, I was moving around the camera in three-dimensional space. So I did create a camera object, and I'm going to cover making that because I think it's something kind of interesting and worth talking about. Position, look at, up. So what I've been using in previous tutorials is, let's see, it would be map for look at function. Yeah, so I've just been using this function right here, which generates a look at matrix, a view matrix with the given eye position, focal point, center, and up axis. So I'm going to be encapsulating all this in a camera object that then we can also update. We can say, like, move the camera forward, whichever way it's looking, move it to the right, have it, you know, rotate up, rotate left and right, kind of a first-person shooter kind of thing. Though I'm not going to be using it like with a first-person shooter. You won't be able to look up and look down. You will be able to move up and move down. So what I'm going to do is I'm going to say I need to keep track of three different directions. I need forward, which will be vec3.create, this dot up, it's going to be another vector3, and right. And if we have these, we have three, oh shoot, I'm forgetting my linear algebra terms already. So these three vertex, or these three vectors will be all orthogonal to each other, and because of that, we'll be able to form a complete space with it. And using this one as well as the position, I guess I should keep track of the position, huh? So using the up and the position, we will be able to generate one of these look at matrices. So let's see. Oh yeah, and then the forward will serve as our center. It'll pretty much, we'll just say where are we. Alright, our look at is going to be where we are plus where we're facing. Alright, so now let's actually do the math. So to get our forward direction, which way is forward, I'm going to subtract the look at vector from our position, and that will give us where we're looking from our point of view. So subtract look at from this dot position, and that's just using the vec3 subtract method, which you can see the documentation. All this documentation is on glmatrix.net. Alright, vec3.subtract. Now what I want to do is I'm going to do a couple of cross products in order to get those orthogonal directions, because we have a forward. Right, as of right now, we have a forward direction, and we also have an up. The up is not strictly orthogonal to this forward vector, or it's not strictly perpendicular, to use that word instead. And so we need to find a right vector and an up vector that are both perpendicular to this forward director. And the way we can do that is with the cross product. So the first one I am going to assign to this right, so our right, which way is right, is going to be the cross product of which way is forward and which way is up, though this up doesn't necessarily have to be orthogonal to forward. So let's find the orthogonal up vector, and that will be the cross product of whichever way is right and whichever way is forward. Great, and so this should give us 3 orthogonal vectors. Let's now make them orthonormal by normalizing all of them. So we'll normalize everything, and this will give us an orthonormal space for our camera. Great, so this is good constructor. At this point we now have a camera with the capability of looking forward, or producing a view matrix, as well as like we have which way is forward, up, and right. I'm just going to write one more method for this right now. And then it'll be the get view matrix. And we will use this to get the view matrix of this particular camera. So let's see, should I allocate memory every time, or should I input? You know what, I'm going to change from the sample code, and I'm going to say out. I'm going to do kind of what the GL matrix norm is, and that's going to be I'm going to set this memory instead. I'm going to assume that this is a constructed map for instance. So let's see. I want... Okay, looks like I will have to allocate some memory anyway, so that's okay. Because I want to look at out is where I'm going to be outputting everything. This dot position is where we're at, so let's let me make sure I'm getting this all right again. Oops, look at. So yes, I center up. So we are placed right there, and the center of our world is going to be... And this is the part that I'm a little bit not proud of. You know what? Yeah, I'm going to do this. I'm going to create... Vec3.add, look at this dot position, this dot forward. So all this is doing right here is I'm going to say I want to create a look at position. It's just going to be the addition of where we're standing and where we're looking. So nothing too fancy. Look at, and then finally the up direction is this dot up, and then I'm going to return out, just for, again, I'm kind of following the GL matrix for all the math here. And I'm going to add some methods later. Actually, you know what, I'm going to add them right now. I'll just copy them in, though, to give us a couple of other things. I don't really feel like covering the math here, so I'm not going to. I'll just briefly breeze over them. I want to change that variable name. I think everything else stayed the same. Hello. Okay, good. Great, and so this is giving us a rotate up, and rotate up we actually won't use at all, so I have no intention of doing that in this demo. The rotate right, this is going to give us the ability to turn the camera to the right, so stay in the same position but rotate the camera. Then we also have our move forward, strafe right, and move up. This will allow us to actually move the camera a certain amount of distance, so that then later when we call the get view matrix, it is updated where the camera is. So, yeah. So, you know, it's going to be pretty useful. Let's see, and I think that's everything I had in the model.js that I wanted to do. Yep, it is. Great. So, the last thing is I'm going to put up some of the boilerplate for our actual light map demo scene. Let me just copy that name because it's really long. Yeah. It's Control N. Light map demo scene. So use strict, because why not? So for all the scenes from this video and out is I'm going to create objects that have a certain interface of methods, and it's just going to make programming easier, especially when I start to introduce things that do have multiple scenes. I plan on doing a video later, which is how to integrate a loading screen really well, because this demo especially is going to take a long time to load, and so the user is just going to be staring at a blank screen for a bit. Light map demo scene. So I'm going to be making these objects that all that they do is they take in an OpenGL context, and from there they do everything else. The methods that I'm always going to have are going to be prototype, a load, where I load everything that is required for the scene to operate and invoke a callback when I'm finished. I also want an unload, though this is not as necessary, and this is just going to free up all the memory resources that we have. So pretty much in WebGL, the resources on the GPU are released when there is no longer anything on the GPU that requires them, so there's no GPU resources that require that particular buffer, and there's no more JavaScript variables bound to that. So once the JavaScript garbage collector goes through, it'll clean up all of like the buffers that we create on the CPU side, and that'll go through on the GPU side as well and clean them up once nothing any longer requires them. Yeah, so I'm just going to include that for good practice, though I don't see a need to have it right now. Next, I'm going to have a begin function, and this I'm going to invoke as soon as everything's loaded and we're ready to actually start rendering the scenes. This begin is going to start our render loop, prototype, end. And the last one I'm going to have is this end function, which ends the scene and also detaches any event listeners and all that. The idea is the lifecycle of this should call the load function. After the load function is finished, it should call the begin function. The begin function will begin rendering everything. When you are ready to switch scenes, you will load the next scene. When the next scene is completely loaded, that's when you will call end and then immediately unload on the current scene. That's kind of my idea. It might not be the best, but hey, it's going to work. At least it works for these demos when I only end for other demos where I have multiple scenes. So let's see. I guess now I just need the app.js, huh? This one's actually going to be probably the shortest file that we have. Whoops. And I'm going to keep a global instance for now of our actual demo. And I'm going to have our function init in here. So in here I'm going to actually get the JavaScript instances of what we need. So canvas equals document.getElement by ID, GL surface, var GL equals canvas.getContext, WebGL. You know what, I'm just going to copy this part over as well because I've already done it 1,000 times. If we didn't manage to get the WebGL context, grab instead the experimental WebGL context. And if that failed, then give the user an alert that they need to get a better browser. Let's see, or a better computer, I guess. Though, like I said, I haven't run into any problems with vanilla WebGL on any of these demos that I've done. So right now I need, demo is going to be a new, what did I call it? You think I'd be able to remember this for more than 2 seconds, huh? You would think wrong. So demo equals new lightmap demo scene. I'm going to attempt to load it. Was I using capitals or lowercases? I was using capitals. Demo load error, demo load error. If there is a demo load error, then I want to alert the user and then also do a console.error demo load error. Otherwise, I want to demo.begin. Great. Cool. So this will load and begin our demo. So just to make sure everything's working, inside the load, I'm just going to call back right away. Let's see. Console.log, loading demo scene. Let's actually do a set timeout for 1.2 seconds, and then once it's loaded, console.log, beginning demo scene. Great. So I think that should give us everything we need. Let's start our HTTP server. And this is just something that I installed using npm. The actual command that I use is just npm install HTTP server. It starts a basic file server. All it does is it serves what's in whatever directory you happen to be in. And it does it on port 8080. So if we do that, how are we looking? That's not right. There we go. That's what I was looking for. No, it's not. Oh, right. I called it FPS camera before, and I just called it camera now. Alright, so it looks like loading, beginning. Okay, so all that's happened so far without error. That's good. So now that I've breezed past all that stuff, let's actually get into the interesting stuff. So the actual scene that I had, let's pull up. Let's see, I think I had it under here. Was where I was keeping it before. This is our blend file. Was this it? Let me just make sure this is the one that had all the scales and stuff, right? Yes, this is the right file. Okay. Yes, I do want to quit. I can't imagine what I changed. So I'm just going to copy this Blender file, and I'm going to bring it over here into shadow mapping video. Boom, right here. We have a room.blend. And I had downloaded previously the async2json library, so I'm just going to call that. So actually first let's go into the directory so we don't have to do a billion directories. Shadow mapping video, and I have mine under fdownloads async2json release async2json.exe. The input is going to be room.blend, and the output is going to be room.json. Boom. And it has everything in there. Great. Don't need that anymore. So now we have that object and we can load everything. Perfect. Okay, so in the load, I'm going to use async because I'm only going to have two different types of resources that I'm going to load for this tutorial. I'm going to have the models that I'm going to have to load. All of them were in the room.json object that had all of the models. If I had separate blend files, it would be separate assets. But that one I just kept the entire scene in one file. So it's really just one model, but I'm going to load that as a JSON object. And then I also have shader code that I'm going to be loading, which I will write momentarily. So I'm going to use the async.parallel method. And when everything inside the async parallel is finished, I want load errors and load results in this function. So if we have any load errors, I just want to call back with those load errors and be done. Otherwise, yeah, I'll keep it like that. Otherwise, I'm going to do stuff with all those resources. But first, let's figure out what resources we want to get. So the first one, I want to get model resources, function callback. And for each one of the async.parallel, let's actually, do I have a... I've used this in some of my other videos, but like I said, I'm assuming that you haven't actually seen any of my other videos. So this method right here, I'm going to be giving it, I'm doing it in object form, so kind of like this. You give it a whole bunch of tasks that you want it to complete in parallel. It's single-threaded JavaScript, so it's not truly in parallel. It's just saying it doesn't matter what order they happen in. Each one you give it a function that has its own callback. The callback then gives back the error, which in most cases should be null, and the result, which happens to be, in my util.js, what I'm doing for all of my callbacks. Is I give it an error, and then the second thing is the result. So I've been doing that very much with async in mind. And then after that's all finished, it gives you an object with all of the errors and all of the results. And if there's no errors, this load errors object will be null. So, anyways, that aside, why is that? Why is that the title? Oh, because I didn't manually set the title. Ah, there we go. Let's see, so if no load errors happened, wait, that's not where I'm wanting to look. I'm wanting to look up here in the models. I'm going to use another method, the async.map. Okay. Which takes in an array of items, or an object of items, applies a function to it, and then for all those, it gives you either the error that one of those functions returned or a result containing the same array or object, just with a populated result. So for all of our models, I know that I want to apply the load JSON resource method that I wrote earlier, and I just want to send it straight back into the callback method. Or the callback for this parallel invocation. So room model room.json is the name of the object. That's going to be it for that. And the shader code. For this first video, I'm going to be doing something similar, but I'm only going to be loading 2 shaders for now. By the end of this whole thing, we will have written 6. So the first one is I want to write a shader for something that does not receive any shadows. I will also be writing a shader for something that does receive shadows, and then a shader to compute those actual the actual shadows. So let's see, shadow, no shadow. Yeah, I'll just write it no shadow. And no shadow, fragment shader text. It'll be under shaders, no shadow, fragment shader, GLSL. So let's actually write those files just really quick. I'll make a new folder called shaders. I want no shadow.vs GLSL and no shadow fs.glsl. Let's see, and if we run it at this point, we still shouldn't have any problems. Yes, we look good. Except for there is one problem. This is still where we're invoking the callback, so even if we had problems, we wouldn't know. Let's see. So let's just move... Nope. We'll move that inside of here instead. Great. So it looks like we're loading everything. Here we have our model. Our room model is loaded. And let's just make sure we have everything present. If I look in meshes, yes, we have our monkey mesh, we have our table mesh, we have our sofa mesh, we have our light bulb mesh, and we have our walls mesh. All of them have vertices, normals, and faces. So it looks like we're loading our scene properly. And our shader code, of course, we don't have anything yet. Great. So next up, let's actually write those shaders. So the shaders are going to be somewhat simple. They're pretty much going to be the same one I was using in my Fong lighting tutorials. It's just going to be a basic lit shader, but I'm only going to use diffuse and ambient lighting. So for the vertex shader, we need our projection, view, and world matrices. We need the position and normals at every vector. Remember, for colors, we're doing it per mesh, not per vertex. Varying vec3 is going to be the fragment position and fragment normal. Alright, so in this I'm just going to set... Oh yeah, by the way, the reason that we need the fragment position is just for lighting, and we're also going to use it for shadows. So, yeah, thought I'd mention that. Actually, strictly speaking, for lighting, we really don't need this fragment position. Oh, yes, we do. We're doing a point light, not a directional light. I lied. So I'll shut up now. I shouldn't shut up. I'm writing a video about how to do things here. You're literally watching this to hear me talk about how to do this thing. I won't shut up. Alright, I'm just gonna... The position in normal, I want to get it in world coordinates. For positions, you use 1.0 for the W component. Normals use 0.0. And I'm just going to pass those into the fragment shader inputs, the varyings. The position of the actual inhomogeneous clip space, I just want to also apply the projection and view matrices to the fragment position that we've already computed. And that should be it for our vertex shader. So essentially what we're doing, we're just grabbing a fragment position and normal for every single fragment. We're doing it from a vertex position and normal that we get in. We're applying the world matrix to it so that the fragment has those things in world positions, and then our homogeneous clip space, we're applying the projection and view also to that world transformed object. Great. So for our fragment shader, we also want to use precision medium p float. For this one, I'm going to have two uniforms. The first one is going to be the point light position, and then the second one is going to be the mesh color. About the point light position, in a previous tutorial I showed something like this where I said struct point light, and then this would have its own vec3 position, vec3, maybe vec4 specular color, and this might have its own vec4 diffuse color, and this might have a float range, and blah blah blah, and fine and dandy. This is probably the better way to do it if you're making something elaborate. We're just making a little tiny app, so all the color for the point light and all that, we're going to be writing that into the shader itself. Exercise to the reader, you can do it the right way if you'd like. I'm not showing lighting in this video, I want to show shadows is the important thing. Okay, so now we'll write this. So the first thing I want to get is I want to get a normal vector that represents from this fragment to the light. So vec3 to light normal equals normalize. I want the point light position minus the fragment position. So this will give from the fragment which way is the light as a normal vector. And we're going to use that in the lighting formula. We are going to be using the Phong lighting model. I misspelled model, whatever. Which I covered in a different video right here. We have all these fancy formulas, and we need which way the light is, and also the normal of the fragment itself. We take the dot product of that, and we multiply in the diffuse color, and that's how we get how much light we want to use. So our light intensity is going to be, I'm going to use 0.6 is going to be our ambient light, and this is just going to be a white light, so I'm not multiplying by any weird yellowish lights or anything. Plus, our diffuse intensity is going to be 0.4. We want to take the dot product of our normal and our to light normal, and we definitely don't want to use anything less than 0, so I'm going to take the maximum of whatever this returns, or 0. Okay? Otherwise, objects on the far side, triangles on the far side of an object from a light would actually receive negative lighting, which is not what we want. Vec4 mesh color.rgb times the light intensity, mesh color.a for transparency. Great, so this should be our fragment shader. And for our no shadow receiving, this should be it. So let's see, let's just make sure that everything's loading all properly. Are we getting the shader code? That looks good to me, that looks good and different, so I'll believe it. Yep, looks good. Great. So now that we have all of those resources right here, let's actually use them. So the first thing I'm going to want to do is I'm going to want to create the model objects. Now you can see if I were to go in here, in our models we have just this room model object, which inside of meshes has 5 different objects. One of them is going to be monkey mesh, one of them is going to be table mesh, sofa mesh, light bulb mesh, and walls mesh. And the reason they are called that is simply because that is what I called them in this room.blend. You may or may not be able to see with this resolution, but I have all these mesh objects I've called light bulb mesh, walls mesh, sofa mesh, monkey mesh, table mesh. And so that's how I got the names for them. Yes, I do want to quit. I have no idea. What did I change? Cool. However, I can't be bothered to remember if they're in the right order. Plus, I really don't know if they come out in the same order, so I'm just going to write a for loop that goes over all 5 of these in the array, and I look for the names. So let's do that. For var I equals 0, I is smaller than load ob. And then the results of the load. I want this models object dot room model dot meshes dot length. I++, we are going to have to do something about that, so let's get which mesh we're looking at presently. Room model meshes at I. Great. So now I'm just going to switch for the name, mesh dot, I believe the property name was actually name, wasn't it? Yeah, it's actually name. So switch for mesh dot name. I'm going to have monkey mesh. You know what I'm going to do right here? I'm just going to copy those. Oh, no, I'll type them out. case. So I have a monkey mesh, I have a table mesh. I'm going to have a sofa mesh. I think monkey mesh, table mesh, sofa mesh, light bulb mesh. And then the last one is walls mesh. Okay, so I'm going to load those all, and I'm going to create different objects. Now, one thing I'm going to do is this is from a global instance, actually, so what I am going to need is I'm going to need to set the GL object of this light map demo scene thing. Yeah, and then I'm also going to be trying to bind more properties to this. So in here I'm going to want to say something like this dot monkey mesh equals new model with a whole bunch of stuff inside of it. However, this is one of those JavaScript gotchas. I'm not sure how much you've used JavaScript before, but this is absolutely one of the things that I hated, is that this keyword is going to be bound to this object. However, you have what's called the functional scope, and so because we're inside of a callback function right here, this will actually be bound to something internal within async. I have no idea what this is going to be bound to. So let's just make something, we'll call it me, and we'll bind it to the this variable within this function scope so that we have a reference to it. So instead of saying this.monkeyMesh, I'm going to say me.monkeyMesh. Get used to doing that if you're going to get into JavaScript programming. Seriously, this threw me for a loop when I was learning JavaScript for the first time. Great. So I am going to make a new model. So the model parameters were going to be GL, the vertices, indices, normals, and color. So if we go back, light map demo scene, we can probably close a couple of these files now. I'm done with them. Yeah, I'm done with those ones all. So our GL is going to be me.gl. Our vertices are going to be the mesh.vertices. Our faces, this is going to be kind of, we have to do a little bit of a weird JavaScript hack. So let's see if I can find the original Stack Overflow post that I got this hack from. JavaScript flatten array. Maybe it's flatten array of arrays. Yeah, so we're wanting to do something like this because all of our faces, when we get them, it's going to be a whole bunch of arrays, each containing 3 elements, each one of those 3 being a triangle of its own. And we want these all in one giant list instead of in a list containing a whole bunch of lists. So yes, this is it right here. This is the Stack Overflow post. So I'm even going to make a little comment for that, cite my source, because I'm a good programmer. Array flattening trick from here. Even though I'm pretty sure this is common knowledge at this point, I just haven't actually memorized this. I'm going to do a empty array.concat.apply empty array mesh.faces. This is going to be our list of indices. Mesh.normals, and then our position, is that what the, oh no, this is going to be our color. So vec4.fromValues, let's see, for the monkey mesh, let's do, I think what I had before was 0.8, 0.8, 1.0, 1.0. This would be the perfect opportunity to make them less stupid colors, but I'll just keep the original ones. Let's see, and so now we should have this monkey mesh object that has all of these properties, VBO, IBO, NBO, a number of points. These we don't have to care about any further. The color and the world transform we are going to use. So the world transform, let's set it to actually where that monkey is, where we want it in the scene. So first of all, I'm going to rotate it just a little bit. And kind of just as a little trick, let me open back up my Blender window right here. So what I'm going to do right here is I have this object placed in the scene as I would like it to be. If you can read it up here, it lists in this window, which, how do you, I think it's the N key. Yeah, if you press the N key, N is in, I almost made an Archer joke, N is in Nancy. If you press N as in narwhal, it brings you up this property over here. The top one is the location, then you also have rotation. I'm going to be using both of these. And instead of axis angle, let's get a quaternion. Yeah, for the rotation of that object. Well, No, the rotate requires an axis and an angle, so let's do axis angle. Okay, great. So the position is going to be 2.07919 negative 0.9855, and then z is 1.757, and the rotation is going to be 94.827 degrees about the negative z axis. So let's apply those to the map. For.rotate, me monkey mesh.world, me monkey mesh.world. I want to rotate 94.87 degrees about the negative z axis. And then after I'm done rotating, I want to translate 1 point... Oh, that's right, I had changed these slightly. I'm going to use the ones that I see in Blender, though, for now. Because I know those are also good positions. This is what I was using before. Oh, that's just 2 5s, and just 1 minus sign. I actually kind of wonder if it would compile if I did that. Okay, so I'm just grabbing those from Blender. And so, me monkey mesh world is starting out as the identity matrix. I'm doing a rotation and then a translation. If you're doing manual transformations like this, you should do them in a very specific order. It should be scale, rotate, translate. Otherwise, it's not going to do what you're expecting to do. If you do a translation and then a rotation, it will move the object over and then translate it around the original origin. So, you know, it'll move out here and then rotate over to here, which is not what you're expecting. Great, so that should do the monkey mesh. Yeah, let's fill in the other ones as well. The table mesh, these ones I'm just going to copy over directly. I'm not going to go through the time explaining what I'm doing, or actually typing it out. Right here you can see I'm just making a table mesh, where I'm grabbing the vertices, same concat apply, mesh normals, from values. This one is going to be a combination of red and blue, so what is that, like a purplish color? The translation I think might be different than before. Oh, goody. Location 000. That's not... Oh, that's the room. Whew. That's good. Translation I want 1.57116. I want 0.79374. I think I had moved them so that you could see the shadows just a little bit better, but I want to show the process how I was doing this from the Blender file, because I think that's kind of important. Great, and the table mesh doesn't need to be rotated at all. So let's now grab the sofa, light bulb, and walls just in one go. The walls I don't think actually need to be moved at all. Those are going to be, the origin is going to be the center of the room, so that doesn't need to be moved. The light bulb itself, let's see. Oh, light bulb specifically. I'm setting a me.light position. The reason for this is later, so in the next tutorial I want the light to actually move. For right now I don't want it to move, but I am still going to create this separate variable light position. Anyways, so let's see. And I want this to be at 0, 0, 2.7... I want that to be at 2.98971 is what it looks like it is in the scene. And then the colors, I'm doing extra bright for the red, green, and blue, just so that it shows up bright white no matter what. So I'm going to have too bright of values, but that's okay. I want it to be bright white. And then I'm translating this one to be at the light position. I'll adjust that so it's a little bit better to read. Finally, the sofa mesh, let's make sure that we have the values right here. Okay, this one is going to be whatever combination that is. It came out to be some sort of teal color. Negative 3.287, I don't think I moved that one. This is going to be 77518 for the Z. Actually, I'm going to keep that one a little bit higher, because I think if I remember right, in the actual blend, yeah, the table legs went just a little bit too low, a little bit lower than I wanted it to be. Also, these things, if you really want to do things the right way, I believe all of these transformations... Is this the walls mesh? Oh, here we go. Let's see, so the transformations, okay, yes, yeah, so they're not right here. I think you'll be able to access it somehow from this root node object. Yeah, so the table has this transformation, so you can get the transformation matrix directly. I didn't really want to go through the work of connecting these names to the other names and getting all that worked out, so I just kind of manually put them in for now. Let's see, great, so that should be all of that. I'm now going to put in some checks to make sure that I load all of the meshes by the end of that for loop. So if the monkey mesh isn't loaded, or the table, or the sofa, or the light, or the walls mesh, just return and call back with an error. So if we run that, yep, it looks like everything is still fine, so we are dandy. Awesome. So let's see. So I am going to want to set me.noShadowProgram is going to be the result of create shader program. And this is another function that we just wrote in here, if you remember right, the create shader program. I need to give it the vertex shader and the fragment shader text. And then I'll need to make sure that it doesn't have an error object associated with it. The parameters were GL vertex fragment text. So me.gl load object, load results dot shader code dot no shadow received vertex shader text, load results, shader code, no shadow, fragment shader text. If me.noShadowProgram.error, then callback me.noShadowProgram.error and return. Looks like everything's great. So if I look here at the demo no shadow program, we do have a WebGL program. Fun fact, here's a little JavaScript hack for you if you want. This same piece of code right here, if all you're doing is you're checking an object and then you're invoking something, well actually this wouldn't be a good example right here, but no shadow program.error and cb me.noShadowProgram.error. This is just a fun little hack. It says if this error object exists, then invoke this callback method with the error in it. So I don't know. Thought that might be worth mentioning. Great. Let's see. So I do have a couple of uniforms and attributes, and what I actually am going to do is I'm just going to use the wonders that are JavaScript, and I'm going to attach those uniforms and attribute locations directly to this noShadowProgram object. So I'll say me.noShadowProgram.uniforms and me.noShadowProgram.attributes. And let's see, if I were to, let's do that instead. And in here we will open up our vertex and fragment shaders. In our vertex shader it looks like we have 3 uniforms, a map, proj, view, and world. So let us get those 3. I'll do it this way. So I'll copy all those. I'll paste them in. Let's get the formatting right on those. And then I'll do a me.gl.get uniform location. I want me.noShadowProgram is the program we're using, and the name of the attributes are going to be mproj, mview, mworld. Seriously, if you don't use Sublime Text, you are missing out. And the attributes are going to be position and normal. me.gl. And this is going to be a get attrib location, no shadow program, v position, and v normal. And so I'm just getting the uniform locations, the handles on the CPU side to the uniforms and attributes that we're going to be using for these shaders. Yeah, and then we have 2 more uniforms right here that I need to get. How did I do that? That's how I did it. Okay. me.noShadowProgram. Oh, no. Oh, no. That will not do. Alright. Great. So now we have all of our uniform and attribute locations. So if I were to run this again, light map demo scene is undefined. What did I do? Line 124, there's an error. me.gl get uniform location, point light, position. Oh, right. I forgot to put that comma back in. Really, I think JavaScript allows you to put commas at the end of things, even if they're at the end of the object and all that. Yeah, it does, so that's fine. So now I should have this no shadow program, which is the WebGL program with these extra things attached to it. So I have, the normals and positions of all this. Now, this is actually something I noticed while I was debugging on other computers. Some browsers and operating systems, I really don't know what the distinguishing factor is. If they're not actually used in the shader, it will give you a null, and it will kind of yell at you. I think with these, because our shaders are complete, it's not giving us any problems. But if you're running into that during development, that is something known, and it's annoying. I really don't have any good advice for you to fix it. Just know that that's probably why you're getting a null, is if it's not used. Great. So I think that gives us everything that we need for that shader. So now let's get a spot for our logical values. And I think the only logical ones that we need is we do need a camera. So camera is going to be a new camera. And for the camera, we used position look at up. So for the position in the scene, I want to start from values. Let's do 0, 0, and 1.85 on the z-axis. Now, something I'm going to do for this scene that's just a little bit different. Again, if you go back to the Blender, you'll notice that in the Blender scene, Z is pointing up instead of Y, which is what I've used in other tutorials. That is a-okay. It's a matter of perspective, so I'm going to do X and Y being the horizontal axes and then Z pointing up instead. So we're going to start out just slightly up in the air, but in the middle of the scene. Our look at is going to be vec3'd up from values, negative 0.3, negative 1, and then also just that same 1.85 slightly up in the air. From values, 0, 0, and Z is our up direction. Great. So that gives us a camera. And then, I think that is everything we are going to need to at least start drawing the scene. Yes, I do really want to quit. Okay, looks like everything is loading properly. Perfect. So this is going to be all of our asynchronously loaded resources. And inside the load function, I'm just also assigning everything that we need to variables. Everything outside of this, we should be able to do just in like the render loop. We shouldn't need any extra additional information. For our unload, because I do want to kind of show off how I intend to do this, I pretty much just everything that I've set in here, so I can even just look right here and I can see all the objects that I've set. I just want to unset all of those and unload. Any of them that require GPU resources at least. So all of these meshes will need to be unset. So me light mesh equals null, me monkey mesh equals null, me table mesh equals null. Right. We haven't set me, so let's actually do this. I'm so used to doing asynchronous programming that I just always set me equals this at the beginning of stuff, and I forget where I don't. This dot sofa mesh equals null, and this walls mesh equals null. Our no shadow program also uses a GPU resource, so I'm going to set that equal to null. Our camera doesn't actually use a GPU resource, so for video memory we don't have to set it equal to null, but I'm going to anyways. This .gl we want to keep. Oh, this light position. We do also have that, and I believe that covers all of it. Yes, it does. Cool, so now in our begin we can start to write our interesting code. So, for now, let's see, let's just get a scene rendering, and not do anything more than that. I am going to write a couple of private members down here, or, like private, quote-unquote. I guess maybe I could actually do that inside here, so that they could be truly private, not accessible. I'm trying to decide how I want to do the scope here. Because I have to fight between either having true scope, where I won't be able to say, like, because from right here I can say demo.begin, and I can call that method. And I can do that from anywhere. And I want to have a function just for rendering, but I don't want to be able to call it like this. Like, I don't want to be able to invoke the render method. So I have two options. I can either set as a prototype another function called render. Maybe I do it with an underscore, so I, the programmer, know that it's private and I shouldn't ever be using it outside of this light map demo scene. Or, to make it truly private, I could do something like this, and I could say this.render equals function. The problem with this, however, becomes for every light map demo scene, you now have a new object, this render object. For the scenes, I don't think that's going to be a problem because we're not going to have multiple of these scenes going at the same time. So I wanted to talk through that process so that if you're, planning on making something where you have 12 different canvases all doing different things, maybe to use this prototype instead. But for me, because I want to keep this truly private, I'm going to place it in here, this render equals function. And I'm going to have a couple of private functions. And actually, you know what? This actually doesn't make it private either. In order for it to be truly private, I would have to write those functions in whatever uses it. And because I want this entire object to be able to use it, I'm just not going to be able to do anything private. I thought I was going to be clever there. I guess that's what I get for thinking I'm going to be smart. Okay, so I'm going to write a couple of methods. These are just kind of game loop kind of methods. We'll have private methods, and then we'll have, down here I'll put our event listeners. So the update's going to be called every frame. It's just going to update the world. So all the animations that we had running, we're going to take care of that animating in here. The render is going to do nothing more than actual draw calls, and sending over uniforms and stuff like that, but only drawing related stuff. Great. So in the begin, I want to get going a render loop. So we'll set this because I am going to be doing some asynchronous stuff. I want to add a couple of events, so add events, and then render loop. I'll do that in just a minute. So the actual render loop that I want, let's see, the information that I'm going to need, let's have a var loop. Great, so with request animation frame, anything passed into that method, it'll be a function that then it will call that function with one parameter, and this parameter right here will be the result of performance.now. So actually for frame rate reasons, let's say var previous frame equals performance.now. Great. So now we'll be able to compute a delta time. Just one little trick that you can use. Try to allocate your memory outside of the actual render loop so it's not being created and destroyed every frame. I think the optimizer might take care of some of that, but I usually like, just as a rule of thumb, to try to allocate memory outside of code that gets called every frame, if at all possible. And that comes from me. Really, I am more accustomed to C++ programming, so I think that's just a relic from me doing a lot of that. So let's see, delta time equals current frame minus previous frame. I want to update with that delta time, and then I want to set the previous frame equal to the current frame time. After all that's done, I want to render the scene, and yep, then I want to request the animation frame. Now, I've mentioned that, actually, let's make sure this works. Yay, everything's working. One thing that I've mentioned is, I was just going to say it. What on earth was I thinking about? Oh, right, with scenes. So maybe you want to do something more elaborate. I'm doing this whole scene structure so that I can have a load, an unload, or a begin and an end. One of the things we want to do when we end is we want to no longer be in this loop. Now, request animation frame is kind of a cool function. If you look at the documentation right here, you can see that it returns something, and then that there is a cancel animation frame as well, where you give it whatever this request animation frame gave you, and it will not, it'll stop that function from being called the next time. So I'm going to keep a reference to next frame handle. Next frame handle equals request animation frame loop. And so this will just set this variable, this next frame handle, equal to the result of this request animation frame, so that when we call end, I can say me.nextFrameHandle and cancel animation frame me.nextFrameHandle. And this is where that whole trick that I showed you can do. Let's actually not do that. So if me.nextFrameHandle, if we have that variable, then we'll invoke the cancel. Either one of those will work. This is more clear, so it is preferred. Great. Cool, so now we have an update and a render method that we have to write. Do you like it how I've just been kind of putting off the interesting work until the very end here? How I've been doing uninteresting, boring stuff while you've been watching? Well, this is where it actually we're going to start doing the rendering stuff. Let's see. So I think the update we can actually leave alone for right now. No, let's rotate the monkeys. So map4.rotate, I want to rotate it around the z-axis. This.monkeyMesh. This.monkeyMesh. And how much do I want to rotate it by? Let's see. So we get dt, which is in milliseconds. So let's take dt divided by 1,000, so that's going to be how many seconds have passed, times 2.math.pi. This will be how many times to spin around. So whatever this next number is, this is going to be how many rotations per second we want it to make. So let's do like 0.3. We want it to make 0.3 rotations per second. I'll separate that just a little bit more. Great. Everything seems to be running just fine. So if I was to look at demo.monkeyMesh world, if I was to look at that at a couple of different times, you can see it's being updated pretty consistently. Great. Now for the actual render. So I don't have to type this.gl all the time. I'm just going to say vargl equals this.gl. We'll clear the back buffer and set per frame uniforms gl.dis. Yeah. Yeah, so we want to cull faces. And we also want to do the depth test. We want to set the viewport to 0, 0, canvas.width. Actually, you know what? We shouldn't have to do that. That's something that I had to do in one of the other ones. But what I do want to do is I want to gl.clearColor. Let's go with just straight black. Okay, so if we refresh that, yes, that's what we're drawing. My goodness, that's a tiny little canvas. That's okay. We'll fix that in just a minute. Let's get our render calls all working. So I want to use the no shadow program, and I'm going to get rid of that set timeout for now, because really I don't have a good reason. That was I was going to use that when we had loading screens and just to kind of show that the process was working, but the process is working, so we don't need that anymore. Let's see. So I want to use that program. And the projection matrix I know we want to use. Have I even set? I haven't even set a perspective matrix. My goodness, that's a mistake. Let's do that in the load. Yeah, we'll do that at the bottom, the end of the load function. So we set a camera, and then me.proj equals mat4.create, mat4.perspective. I don't remember exactly what. I do not remember what the parameters for mat4.perspective were. Mat4.perspective. Let's see, it was field of view, aspect near and far. Okay, cool. So me.proj matrix, gl matrix.toRadian. Let's do a 90-degree field of view. Our aspect ratio is going to be me.gl.canvas.width over me.gl.canvas.height. Our near clipping plane, let's do 0.35 units away, and our far clipping plane, let's do 85 units away. Let's get these on their own separate lines. Great. So now we have a perspective matrix. Alrighty. Perfect. Let me go back over my notes. Okay. So let's set the projection matrix uniform matrix 4FV, and the uniform location is going to be no shadow program dot uniforms dot mproj. This is not going to be normalized, whatever that is. in a matrix, and then the actual variable that I want to use is going to be this dot, did I call it proj matrix? Yeah, I called it proj matrix. Great. And then for the view matrix, we're going to use the view matrix from the camera, which, right, I changed some things around, so let's say our me.view matrix is going to be map4.create as well. And you know what, let's do that in the update function actually, where we update the view matrix value. So this dot camera dot get, what did I call it? Boom, 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 get view matrix. I want this dot view matrix. Alright, so this is where we'll actually update the view matrix. And then in here we'll set it uniform matrix for FE, this dot no shadow program. No shadow program uniforms view GL false, this dot view matrix. Great. And then we need to set the light position, gl.uniform, that's going to be a 3FE, this dot no shadow program dot uniforms dot, let's see, was that just light position? I think is what I called it. No, that was point light position. And I don't think for the 3FE call, I think I actually just need the information. Yeah. Okay. That will be this dot light position. Yep. Alright. And then I don't think I need, let's see, do I have any other uniforms that I have to set? The mesh color? No, that's going to be per object. That's going to be per object. This is the only per frame uniforms that we need. Alright, and we're not doing any texturing yet, so we can actually go and start drawing the actual meshes themselves. So I'm going to write in and kind of talk through my process for drawing one of them, and the rest of them I'm just going to copy that code for several different meshes. And really what I could do is I could have an array of meshes that I wanted to draw and just kind of load into that. Actually, you know what? I like that idea a whole lot better. We'll see if this works. I'm not entirely sure it will. Me.meshes is going to be an array with me monkey mesh, me table mesh, me sofa mesh, me light mesh, and me walls mesh. Great. You get over there. You get down there. Alright, so because we're doing that, let's make sure that when we unload, we also set that array equals to null. Great. So draw meshes. For var I equal, yeah, whatever, we can just do that. I is smaller than this dot meshes dot length, I plus plus. This is allocating memory, so that's why I was kind of like, why are we doing that? But, whatever. Maybe I'll change that in a little bit. So for each mesh, we need to set the world position. We need to set the mesh color. We need to bind the buffers, enable the vertex attributes, and then actually draw the elements. So first step is going to be uniform matrix for FE. This dot no shadow program, uniforms, and world, and we're going to set that. I'm going to do this one on 3 different lines because it's going to be really long. GL false, and then this is going to just be this meshes I dot world. Great. After that, I want to set the color, which is going to be a uniform for FE. I guess I do have an actual float32 array, so I'll use 4FE instead of 4F. No shadow program uniforms mesh color. So this will be our per object uniforms. Set attributes. Come on. GL false. No, that doesn't need the GL false. That just needs the color. Great, so that sets our uniforms. Now for our attributes, we will GL bind buffer, the array buffer, and we will bind this meshes I VBO, GL dot vertex attrib pointer, and this takes in 5 parameters. It'll be the attribs. Our position is going to consist of 3 floats each, which are not normalized. Then I'm just going to use 0, 0 because they're going to take up the entire width. There's not going to be any offsets. There's no other attributes inside the buffer. And then I need to enable that property, no shadow program, attribs, v position. Let's do the same thing for our normals now. Whoa. Oh. It's going to be .vnorm. Great. And then finally our indices. So actually, I guess first we can bind the current buffer to null. So we'll bind the current array buffer to null. Let's bind the element array buffer to this meshes I dot IBO for index buffer object. Let's draw the elements. It's going to be triangles. This dot meshes I dot endpoints. GL dot unsigned shorts. And what is this last one? I think it should be 0. It's going to be our offset. Yeah. So that's how many to skip. We don't want to skip any. And then let's clear that buffer space. So let's see, maybe by some miracle, everything will work. Wow, would you look at that? It's a Christmas miracle. Cool, so that'll be our render function. Great, so just a couple more problems. You can see that I can't move. You can hear me mashing the keyboard, nothing is moving. And then you can also see that this canvas is too small. So let's take care of the canvas too small problem first. So down here in our event listener section that I created, I'm going to create an onResize window method. And this I may or may not have done in other videos, but pretty much what I'm going to do is every time the window is resized, I'm going to look at the window's inner width and inner height. That's going to be the viewable area on the window on the page. And I'm going to try to find the ideal height. So if it's X units wide, and I want to keep a 16:9 aspect ratio, how high should it be? If the window is too tall, or if the canvas is too tall to fit inside the window with that ideal height, I'm going to center it vertically. Wait a second, what am I trying to say here? So if the window is taller than the canvas needs to be with that target height, I'm going to center it vertically. If it's not tall enough, I'm going to center it horizontally and instead use a target width based on the target height. So our target height is going to be the inner width of the window times 9 divided by 16. If our window's inner height is greater than the target height, then I want to center vertically. In that case, GL canvas width equals window inner width. GL canvas height equals target height. Oh yeah, I covered this in my Mandelbrot tutorial, except for I wasn't using a 16:9 aspect ratio. I was just letting you resize willy-nilly. For this one, it's usually a good idea to lock on to at least just a couple of different aspect ratios, because otherwise you have to change the projection matrix and you're not sure what you can see, and it's just too many variables to change. So now to center it vertically, so the style left, I'm going to say is going to be 0 pixel, and that'll set the CSS style to move it all the way over to the left. Style top is going to be window inner height minus target height. So this is going to be how much taller the window is than it needs to be. I'm going to divide that by 2, and I'm going to add pixels to the end. One thing that I noticed when I was writing these tutorials for the first time is this doc type HTML. For whatever reason in Chrome, when I was writing it, if I forgot to put this plus pixel, it would just completely ignore this and I wouldn't be able to get anything done. But for whatever reason, if I got rid of the doc type HTML, it would work. So if you're having problems when you're following along with this, take a look at that. Cool. So now what I'm going to do is I'm going to write pretty much just the exact opposite of that if I want to center horizontally. GL canvas width is going to be the window inner height times 16 divided by 9. Yep. GL canvas height is going to be window dot inner height. GL canvas style left is going to be, let's see, this will be the window dot inner height minus what we want the width to be, which I guess we've already set, huh? So I can just say GL canvas width divided by 2 plus pixel. And then top is going to be 0 pixels. So let's see if I refresh that and I do any resize operation. Oh, right, I haven't attached the event listener. But if I were to say demo.onResizeWindow, oops, yes, right, and I'm not setting the viewport, so GL viewport 0, 0, GL dot canvas width, GL canvas height. Great. So now if I do an onResize window, you can see it centers it and sizes it as big as it can be. Okay, so apparently the center horizontally isn't working. What did I do wrong there? Window inner height minus GL canvas. Probably should be height, huh? Or probably should be widths. Yeah, probably should get all my units right, huh? Yeah, there we go. So now it's centering just properly. So now what I want to do is I just want to attach that to whenever the window resizes, and also I guess I want to do it immediately when we're getting ready to start the window loop. So right here I'll just put in a me dot, let's see, what was that? That was on resize window. So I'll do that just as soon as we load. Boom, perfect. To add the event, let's put that in our begin right here. Now we're going to have a couple of, we're going to have something interesting. Actually, let me make sure that I did this the right way. Yeah, GL equals this.gl. Begin. Okay, so this is where we want to actually attach event listeners. Okay. Let me just look at my notes. Okay, so the naive thought might be to do an add event window resize, and then I just want to call this dot on resize window. If I were to do that, as soon as I resize, you can see cannot read property canvas of undefined on 283. The reason for that is there is no this object. So then the next thought might be to bind it, which is properly. Proper. Let me think. What did I call it? On resize window. Yeah. So I can do a dot bind this, which then binds the proper object, so we have our resize working properly now. Great. So this is fine and dandy until we go into our end method. Where's our end? And we go to do the same thing with a remove event. So now if I were to say demo.end, me is not defined. Whatever. We'll do this. We'll actually write the code right. So now if I say demo.end, you can see that the animation frame has been cancelled and the scene is no longer going through the render update loop, but it's still resizing. And that's because this, when it's being called twice, you're now getting two different functions. So instead of that, what I'm going to do is I'm going to, right here, make another variable called like resize window handler, or let's say listener, equals this on resize window bind this. And then I'm going to attach that event instead. Okay, well, that works. And then now when I do the remove event, I can say this dot resize window handler, and I can only do this if this resize window handler is actually present, which, I mean, really, it should be. So let's see. So now if I were to do that and I were to run end, it no longer resizes, so that's proper. So I'm just making sure that I have all my cleanup taken care of. Great, so that's the resizing. Now I just need to add some things for the actual keyboard presses, and that's not going to be too hard. Light map demo scene prototype dot, let's see, on key down. On key up. Oops, then I want to add event this dot key down window listener equals this dot on key down dot bind this dot key up window listener equals this on key up bind this. Great. Let's add these events. Add event. I believe they are called, it's just key down and key up. Alright, we'll do all these removes. Oops. Let's not separate those. Key up. Key up, key up, key down, key down, key down. So in here I'm just going to do a couple of console logs. Great, so now you can see when I press things, I'm getting the events when I both press and release. Cool. You see if I hold down the key, I'm actually getting a whole bunch of keyboard events, so I'm just going to hold down the A key, I get a ton, and then immediately when I release it they stop. All of these are going to have all these things, the code key A, that's kind of what we're interested in, and then the last one's going to be a release, let's see. And then if I call a.end, yes, when I press the keys that no longer happens, so that's good. Alright, so in video games you'll notice the kind of naive option you have is just every time the W key is pressed, move the camera forward. However, that doesn't work because, as you can see with like sticky keys, if I were to press the W key, it pauses for just a second before it starts mashing the W's. And also I'm not sure if it's determined how fast those W's come out if I'm just holding down the W key. So instead what I want is I want an on key down. I want to say, hey, the W key is being pressed right now, and then when it's released I want to say the W key is no longer being pressed right now. So let's set a variable where we can keep track of all that, and we'll do that inside of our load. So me dot, and actually, you know what? Let's do that in our load, but outside of the asynchronous part, because this part really doesn't depend on anything else. So pressed keys is going to be an object inside of our unload. Pressed keys is going to be null. This video is going on for quite a while. I wouldn't be surprised if it's an hour by now. Let's see, so the up key, right, down, left, rotate left, rotate right, move up, move down. So I guess this should be, let's see, let's do this instead. We'll do up, right, down, left, forward, back. And we'll bind those to different keys. Alright, great. Alright, I'm just pulling up my notes really quick. Okay, almost done. So in our on key down, we just want to register that a key has been pressed. So let's see which key it is. And we'll do that with the e.code, which you can see in all of these. Your code is going to be something like key A, key up. So I'm just going to copy over the code so I don't have to rewrite all of it. But instead of, let's see, I was using up, left, right, down. What was our pressed keys object? In our pressed keys we were using up, right, down, left, forward, back, route left, route right. Okay. So we have, we'll move these up here. Okay. So you can see whenever the key W is pressed, I want the up to be true, which up I actually want to change to forward, W, and when S is pressed, I want that to be back. When the arrow up is pressed, I want that to be up, and this I want to be down. So that is a mild change I'm going to make. So when they press W, I want the forward button to be registered. A is left, D is right, S is back, arrow up is up, arrow down is down, arrow right is rotate right, arrow left is rotate left. Okay, so that's what's going to be happening on our on key down. On our on key up, let's do all that, except for I want to set these equal to false. It's going to be the only difference. Great. So now those variables all should be updating when I go in here, but we're still not doing anything with it. That is going to be in our update method. Update. So in here, this is where we're going to actually update everything. And this is going to be another one of those where I'm just going to write a couple of them, and then after that I'm going to just copy and paste the rest of them. So what I want to do is, depending on which keys are being pressed, I want to change the camera. So if this dot pressed keys dot, let's say, forward is being pressed, and this is important, the pressed keys backward is not being pressed, then I want to move the camera forward. So this camera, and I had, in my model.js, I had a move forward method that just kind of added the forward distance to all that. So this camera, move forward, and this is where I get to pick some distance. So I'm going to set just a couple of variables, constants. Let's do that in our load, actually. So me dot move forward speed equals, I think I found 3.5 units per second was pretty good. Rotate speed is going to be 1.5 units, was also pretty good. And our unload down here, we'll set those back equal to null. Great. Update equals function. Okay, move forward. So I'm going to say that's the number of seconds. And I want to move forward with that amount of speed. So now, if I were to take this and reverse it, so if back is being pressed and forward is not being pressed, I want to move backwards at the same speed. Fantastic. So now let's apply that same principle to the right and left buttons, except for I'm going to use the move forward speed instead. Let's do the same thing for up and down. Apply constant speeds to all those. And then finally, for the rotate right and rotate left, this dot rotate speed. Great. So now you can see I'm just using those camera move forward, move back functions, move right, move left, with a positive or negative value depending on how much I wanted to move it. So if I refresh that, you can see that now we have a camera. As I press W, A, S, and D, you can see I can freely navigate around the scene. And so this has been the first video on the introduction to shadow mapping. Oops, it looks like up and down don't work, so that's not good. So I have forward, back, right, left. Did I just say those is up and down? Those might have just been up and down. Yep, apparently those were just up and down. Okay, great. So this has been the first of the two videos. I don't want that full screen. I want that to go away. And all we did is we just created the scene. I showed you kind of the base upon which we're going to be building the rest of the shadow mapping code. If you've made it all this way, congratulations. Thank you for watching. In the next video is where we're actually going to get to generating the shadow maps and using it to cast shadows. So yeah, thanks again for watching, and stick along for the next video.